Okay, show that dy dx is this guy. I don't think this is an issue lah. This one likely you're okay, right? So you part 1, you just to find dy dx. dy dx dy dt. This is just product chain rule then dx d theta, right? Okay. So dy d theta. Oh wow, okay. Not easy. Dx d theta, chain rule, 3 sine theta square. Differentiate sine is cosine theta. Dy d theta on the other hand, product rule. Okay. So 3 negative sine theta plus 3 cosine theta 2 sine theta sine theta. So this is 3 marks. So just separate them. Sine, then just simplify. No stress. Okay, cancel this out. Negative tangent theta. I don't think it's difficult, this part. Show that the turning point when tangent theta is root k lah. Now take note this is in quadrant 1. Now that you want to solve for quadrant 1 means ASTC, all is positive okay, all the trigo ratio. This is quadrant 1, right? Yeah. So just be mindful of that. So part 2, as stationary value, dy dx equals to 0. So 2 cot theta minus tangent theta is equals to 0. So this is 1 over tangent theta minus tangent theta equals to 0. So that will give us 2 tangent theta equals to tangent theta. That will be tangent square theta equals to 2 lah. So meaning to say tangent theta is actually root 2 or negative root 2 lah. But you reject this, okay? As from 0 to in the first quadrant, tangent theta is positive okay? So you reject this. Okay, so you want the non-trigonometric form exact, meaning to say you don't want any trigo ratio lah. For castle, just get out of it. Okay, you're told to find the exact coordinates on the parametric curve. Anything to do with trigo to algebra, always draw the right angle triangle. I don't even know what I want now. I just draw. I don't know, bro. But it's in the first quadrant. So this theta, this is root 2, and this is 1. Okay, tangent is root 2. So this guy will be root 2 square plus 1 square. So this will be what is this? Root 2 square plus 1 square. 3 root 3. Okay. So essentially, sine theta is root 3. Sorry, root 2 over root 3. Cosine theta is 1 over root 3. So x and y coordinates will be sine theta cube. Y is 3 sine square theta. Just sub back into the parametric equation. Cosine theta. So x equals to root 2 root 3 cube. Root 2 root 3 square. 1 over root 3. This will be root 2 root 3 square times root 2 root 3. So this will be 2/3. Okay, if you want to rationalize the denominator, by all means, this will be 2 over root 3. So you can just multiply by root 3 root 3. Okay, like that. So to explain its maximum, you can either use the first derivative test or second derivative test lah. So I think this first derivative test will be easier. if you use the first derivative test, you need to use x and dy dx. So the x is what? The x is this guy here. 2 over 9 root 6. So 2 over 9 root 6 plus 2 over 9 root 6 minus. Okay. So obviously it's 0 lah. You dy dx is this guy here. You put this guy in. Tangent theta 2 cot theta. This is how you get your theta lah. So if you have x equals to 2 over 9 root 6, right? So 2 over 9 root 6, because your dy dx comes from 2 cot theta minus tangent theta, right? So you need to make theta the subject. So when you make theta the subject, you will get this one will be, make sure it's in radian. Okay, just make sure it's in radian. Radian. Then you put this theta inside here. Your dy dx ultimately will become what? 0. Okay. So you key in calculate. You know what I'm saying? So you just x is 2 at the stationary value. This is a stationary value, right? This x will correspond to sine cube theta ma. Okay. So then from here, what you do is actually you get this value here, like 0.9555316. Okay. So similarly, if you want like because 2 over 9 times root 6 is roughly 0.54. So if x equals to 2 over 9 root 6, you want it to be slightly a bit bigger than that, you can put like 0.5445. Okay. Yeah, then you do the same thing. This will be 0.5445 equals to sine theta cube. So theta will be sine inverse cubic root of 0.5445. Okay. This will be 0.95546 radian. You key this into so dy dx when theta is 0.95546, right? Is 2 cot. Cot is 1 over tangent minus tangent 0.95546. Okay, key this in. Okay, so this will be negative. Okay, so you already get the shape. 1 is positive. So that's how you get the plus minus. Okay, so you do the same thing for the, then you get a positive value here lah. So hence turning point is maximum. That's the first method. So if you want to use second derivative test, I think it's easier. It's actually much easier, I feel. So what this is what I'll do. I'll just differentiate with respect to x. So d square y dx square will be equals to 2 negative cosecant square theta. Correct or not? Differentiate cot is negative cosecant, right? But because you're differentiating with respect to x, this is d theta dx. You put it behind, right? Agree? Then tangent theta will be secant square theta. Then same thing, you put d theta dx. This is implicit differentiation. So at the stationary value, we know x is equals to this guy here lah. Actually, at stationary value, we know all these buggers here satisfy ma. You just copy all these down. So you just gather all the ingredients you need, because actually what you need to decide is whether it's positive or negative, right? You can see that this is this over here is given by dx theta you have ma. You have all the ingredients you need, right? So sine theta is actually 3. Let's write it down. This will be 3 root 2 root 3 square. Cosine is 1 over root 3. So this will be 3 2 over 3 1 over root 3 2 over root 3. Okay, so essentially d theta dx will be what? Root 3 over 2. Then you know that cosecant square theta is actually 1 over sine theta square, right? So you just root 3 over root 2 square. So that will be 3 over 2. Then secant square is just 1 over cosine. Then it's just a matter of putting everything in together. So hence d square y dx square when x is equals to You just put into this second derivative expression here. Just sub all the values in, guys. This one, sub it in. This one, sub it in. You got the answer already. So hence, negative, right? Maximum. Because it's the gradient is decreasing. The rate of the change of the gradient is decreasing. Don't just learn one set, like just know both, so that you are more comfortable and know what's going on. Show that the area region bounded by C and the x-axis is given by this guy. Okay, use your calculator to find the area. Now, use your calculator to find the area. You cannot show this one. Please just key in calculator and get that 1 mark, please. Okay? Don't don't go into the... You understand? If you cannot show this one, just key in calculator. Please don't think that you cannot get that 1 mark. Just punch in calculator, give the 1 mark. Then after that, move on to the next one. Okay, it's fine. There are a lot of these kind of questions in A level. So the first thing is to plot the graph. I need to change. Now take note of the parameter, right? So this is sine x to the power of 3. Then this guy will be 3 sine t square. Sine t, right? Now take note, this is not your graph. This is not your graph because this is the first quadrant. Your theta is from 0 to pi over 2. So 0 to pi over 2. This is super important. Make sure you understand it's just this region here. So zoom box to the area. Then it's like that. Okay, it's like that. This is the graph here. Now once you get this graph ready, then you can start ready. This is the graph. You don't need to go and solve it lah. Understand you firstly always test the extreme case. When t is 0, you get 0 here. So this point will correspond to the point. This point here would be the t is 0. T is 0 here. Understand? Then go to GC, trace, put pi over 2, and likely is this point here. Okay, so this is pi over 2. So this guy will be t goes to pi over 2. You don't even need to do anything. So the idea is like I just test the extreme case, the minimum of theta and maximum. So I know the parameter will swing from one side to the other side. When you increase from 0 to pi over 2, it just swings over to this side here. Okay, but that's not the case. So from the GC, you know the graph, this one is just x equals to 1 now. When this is pi over 2, this is obviously 1. So the area under graph, what do? This area here. You just do secondary school stuff, which is like 0 to 1 fx dx, right? So this is the first thing. You write in Cartesian form first, then you change it to parametric form. Changing the parametric form means you just want this to be in a function of theta. This guy dx change to in the function of d theta. Okay, that's about it. So that's all you need to do. But which you already done, like fx, which is y lah. Okay, y is 3 sine square theta cosine theta. Dx theta, this guy here. Dx theta is where did dx theta? Now we have it. So this is dx theta. So what you need to do is just make dx theta the subject. So we know dx is equals to 3 sine square theta cosine theta d theta. Okay, so you just take this dx and put inside here. Yeah, I know a lot of schools don't allow you to write this. Just erase it. I mean, okay, but A level is fine. You don't need to worry about it. Okay, I can assure you. Go to Cambridge University, take any calculus book, right? Everything is written like that. Okay, so don't worry about it. You can just write it. You just make dx a subject, put inside. Okay, if you're but anyway, it's last stretch really lah. Your teacher won't complain about me lah. Anyway, this one dx, put it in. The problem has always been the mistake that always arises is this guy here. A lot of times students forget to change the boundary, because if this is x, this is x equals to 1 and x equals to 0. But once you change to d theta, you need to, this is theta, sorry. This is theta, not t. This is theta. Okay, you need to change the theta. So when x is 0, this guy here, theta is 0 lah. So this is 0. When x is 1, theta is pi over 2. So it is pi over 2. Okay, so remember to change that. Y is 3 sine square theta cosine theta. Dx dt is 3 sine square theta cosine theta d theta. Shown. Okay. Then key in calculator to check get the answer in 3dp. Now if you don't get the answer for this guy, very likely this guy here is not in radian mode. Okay. So now I say and I'll say again, your GC, please keep it in radian mode. Okay. You want the degree mode, put it in your Casio. Okay. Don't never ever change your GC to degree. The rest is very easy because every you forget to change back the radian. The next question parametric form or any kind of area you confirm GG lah. So make sure it's in radian. Part 4, the line with equation of y equals to ax is just a line passing through the origin, meet C at the origin and at point P. Show that tangent theta 3 over a at P. Oh, then find the exact value of a lah, such that the line passes through the maximum point C. Okay. Okay, so you just y equals to ax satisfies C and also the line equation. Then you just substitute it in. Then you should be able to get answer. Part 4. Okay, you just satisfy both equation. So y equals to ax sub the parametric equation inside. X equals to sine cube theta. Then 3 sine square theta cosine theta into y equals to ax. Okay, you want to satisfy both equation. So 3 sine square theta cosine theta is equals to a sine cube theta. So I think that's about it. Divide by both sides, right? This will be tangent. No, this is cot. This is cosine theta, sine theta. And this is that's it lah. So this is tangent theta equals to 3 over a. Passing through maximum point is okay lah, because then at maximum point which we found just now, tangent theta is root 2 okay. At maximum point, tangent theta equals to root 2. A equals to 3 over root 2. That's it lah, that's it.